or a fractal pattern just formed from identical nested pieces? Well, one might think that if one has a simple rule and one starts from just a single black cell, then one would always have to get a pattern that's somehow very regular like this. At least back in 1982, that's what I assumed was true. But one day I decided to try a very systematic experiment and just run every single one of the 256 possible simplest cellular automaton rules. So when I got to rule number 30, this is what I saw. So what's going on here? Well, let's run it some more. Well, there's a bit of regularity over there on the left, but otherwise this looks really complicated, actually kind of random. Well, when I first saw this, I thought it might just be a problem with our visual system, that really there were regularities, but we just couldn't see them. So I ran all sorts of elaborate mathematical and statistical tests, and what I found was that no, so far as I could tell, something like the center column of cells here really was perfectly random. Well, this is rather amazing. We have a very simple rule. We're starting off from a single black cell, but what we're getting out is an incredibly complicated pattern. It seems in many ways random. So it just doesn't seem right. We put so little in, yet we're getting so much out. It's not what our ordinary intuition says should happen. I mean, in our everyday experience, and say in doing engineering, what we're used to is that to make something complicated, we somehow have to start off with complicated plans or use complicated rules. But what we're seeing here is that actually even extremely simple rules can produce incredibly complicated behavior. Well, it took me years to come to terms with this phenomenon, and in fact it's gradually overturned almost everything I thought I knew about the foundations of science, and it's what's led me to spend the past 15 years building a new intellectual structure, really a new kind of science.